We are discussing pavement material and characterization. Previously, we learned about subgrade soil, different tests which has to be performed on subgrade soil, wherein we have learned about shear test, bearing test, and penetration test. Well, penetration test, this may be considered as a small scale bearing test in which the size of the loaded area is relatively small, and these tests are carried out in the field or in the laboratory. The common known penetration tests are the California bearing ratio test and cone penetration test. So let me explore the California bearing ratio test, which is known as CBR test. The California bearing ratio test was developed by the California State Highway Department as a method for evaluating the strength of subgrade soil and other pavement materials for the design and construction of flexible pavements. CBR test is an empirical test which has been used to determine the material properties for pavement design. The California bearing ratio test is penetration test mean for the evaluation of subgrade strength of roads and pavements. The result obtained by this test are used with the empirical curves to determine the thickness of the pavement and its component layers. This is the most widely used method for the design of flexible pavement throughout the world. The value of CBR denotes the measure of resistance to penetration of pavement material or soil of standard plunger under controlled condition. This leads to know the basic principle of CBR test, and that is causing a cylindrical plunger of 50 millimeter diameter to penetrate into the soil or the pavement material to be tested at a rate of 1.25 millimeter per minute. The loads required to cause 2.5 mm and 5 mm penetration of the plunger in the soil material are recorded. The CBR value of the material tested is expressed as a percentage of standard load value in a standard material. The procedure of determining the CBR value is standardized by various agencies including BIS, which is Bureau of Indian Standards. Before moving to the detailed procedure, first of all let me explain what are the equipments and tools required for the penetration test. So first we need a cylindrical mold with inside diameter 150 mm and height 175 mm, provided with detachable extension collar 50 mm height and a detachable perforated base plate 10 mm thick. The second equipment we required is spacer disc, which is of 148 mm in diameter and 47.7 mm in height, along with a handle. Third, we need a metal hammer, which supposed to having a high weight 2.6 kg with a drop of 310 mm or a weight 4.89 kg with a drop of 450 mm. 4. We need a set of weight, one annular metal weight and several slotted weight weighing 2.5 kg each, 147 mm in diameter with a central hole 53 mm in diameter. Next, we need a loading machine with a capacity of at least 5000 kg and it equipped with a movable head or a base that travels at a uniform rate of 1.25 millimeter per minute, complete with a load indicating device. A load indicating device is must. Next, we need a metal penetration piston of 50 mm diameter and a minimum of 100 mm in length. Next, we need 2 dial gauges reading to least 0.01 mm. Next, we need a set of sieves that is of 4.75 mm and 20 mm IS sieve, and few miscellaneous apparatus such as a mixing bowl, straight edge, a scale soaking tank or a pan, drying oven, filter paper and containers. So these are our equipment and tools which we required during the penetration test called California bearing ratio test. So now let's start the preparation of the test specimen. To prepare a test specimen, first of all, about 40 to 50 kg of soil sample is to be taken for dry and it sieved through 20 mm sieve, and the material passing this sieve is used for the CBR test. The optimum moisture content, which is generally known as OMC, and a maximum dry density of the soil is determined by adopting either IS light compaction test with IS 2720 part 7 for heavy compaction test. Now the estimated quantity of dry soil required to prepare one CBR test specimen is weighed and placed in the tray or a pan. The weight of water required to be added to this soil sample to bring the water content to optimum moisture content as obtained from the compaction test. This quantity of water is measured out, sprinkled over the dry soil in the tray and is thoroughly mixed. For preparation of specimen by IS heavy compaction, the moist soil sample taken in the tray is divided into 5 equal parts and compacted in 5 different layers. Each layer is compacted by imparting 55 well distributed blows of the light rammer of weight around 4.85, which is nearly equal to 5 kg. After compacting the fifth layer, the collar is removed and the excess soil above the top of the mold is evenly trimmed off by means of the straight edge. 3 such compacted specimens are prepared for the CBR test. About 100 grams of soil sample is collected from each mold for the moisture content determination from trimmed off portion. The mold with compacted soil inside is weighted so that it is possible to calculate the dry density achieved. Now to prepare undisturbed test specimen, the steel cutting edge of 150 mm internal diameter is fitted on the CBR mold, and this is pushed into the ground subgrade, gently causing least possible disturbance to the specimen inside the mold. When the mold is pushed sufficiently deep, that is filled with the soil in place, the soil under the mold is dug and the mold with the soil sample inside is removed. Now excess soil from top and bottom surface of the mold are trimmed off by means of the straight edge. The weight of the mold with undisturbed soil sample inside is determined. That will be stay inside the mold. From the weight and inside volume of the mold, the wet density of the sample is calculated. The moisture content of the trimmed off sample is also determined. Knowing the bulk density and the moisture content, the dry density of the sample is calculated. This is the whole procedure of preparing a test specimen. Now your test specimen is ready for the test. So now our next target is to perform a penetration test. For that, the mold with the specimen is clamped over the base plate and the same number of surcharge weight are placed on the specimen. The mold with the base plate is placed under the penetration plunger of the loading frame. Here we can see this is a plunger. Okay, so the mold with the base plate is now placed under the penetration plunger. So the mold is here, the penetration plunger is here. Now a setting load of 4 kg is applied. So the first setting load is 4 kg. Now the dial gauge of probing rings for load readings is set to 0 considering the seating load of 4 kg which was applied initially. That means when you start the test, at this dial gauge will show the reading of 4 kg. At that moment our probing ring will display the reading as a 0 for the initial level. Now next, the load is applied through the penetration plunger of the motorized loading machine at a uniform rate of 1.25 mm per minute. So our uniform rate for the loading will be 1.25 mm per minute. The load readings are recorded at penetration readings of 0, 0.5, 1 mm, 1.5 mm, 2 mm, 2.5 mm, 3 mm, 4 mm, 5 mm, 7.5 mm, 10 mm and 12.5 mm. So these are the penetration readings when your plunger will penetrate at 0.5 mm, after that 1 mm, 1.5, 2, 2.5, 3 mm, 4 mm, 5 mm, 7.5, 10 and 12.5 mm, the last. After the final reading, the load is released and the mold is removed from the loading machine. About 50 gram of soil is taken from the top of the specimen for the determination of moisture content. At the end, the CBR value is expressed as a percentage of the actual load causing the penetrations of 2.5 mm and 5 mm. We have conducted this penetration value at a different penetration distance, but for the CBR test we are taking 2.5 mm and 5 mm as a standard load. The formula to find out the CBR, to calculate the CBR, is load carries by the specimen divided by the load carries by standard specimen into 100. So here we will get the CBR value in percentage. The standard load values are already established, that is, for the penetration at 2.5 mm we have standard load 1370 kilogram, 1370, and penetration at 5 mm we have standard load 2055 kilogram. So this is what we are performing penetration test, which is known as a CBR test, and this is the value of CBR. Next we will see how we can obtain CBR value from load penetration curve. Thank you.